When people think of building AI apps, they often imagine creating a prompt and calling an API like OpenAI and Entropy. But real AI app development goes beyond that. It's about fine-tuning, customizing, deploying open source models like Llama, Mistral, or Queen. And once you start doing that, you quickly meet the biggest monster in AI development, Dependency L. You are not just managing Python packages, you are managing CUDA versions, GPU drivers, model weights, and a web of libraries that all depend on each other. In this video, we will break down the top 5 dependency problems that makes AI development way harder than traditional software development. In traditional software development, dependencies are like simple libraries that you can install with npm, npx, pip, or maybe a database driver. But in AI development, dependencies goes much deeper. You are dealing with frameworks like PyTorch or TensorFlow, GPU drivers and CUDA versions, model weights and tokenizers, data sets, and sometimes compiler versions for binary builds. Each of these layers can break your setup. That's why managing dependency is much difficult when building AI apps. Let's start with problem 1. Frameworks and library version conflict. You upgrade Transformer for a new feature, and suddenly your fine-tuning code crashes because a model class changed. Or you update PyTorch and your script stops working because a function is now deprecated. AI frameworks evolve fast, and even a small update can break your code. The solution: always use virtual environments and pin versions. For example, with poetry.lock, VNF, or conda-env. Never install libraries globally or use pip install --, upgrade blindly. Treat your environment like your code base because it is. Problem 2. GPU driver and CUDA incompatibility. The model might require CUDA 12.1, but your GPU driver only supports 11.8. Boom! The model can't run on GPU, and you spend hours debugging what looks like a code problem, but it is actually a dependency issue. This is dependency L at the hardware level. This happens because deep learning frameworks are tightly coupled to specific CUDA versions. The solution: use tools like CUDA, Docker, or containers to lock in mismatching CUDA and driver versions. They keep your setup consistent across machines, local, cloud, or your teammate laptop. Problem 3. Deep dependency chain and binary build. Installing one framework often pulls in dozens of other packages like math libraries, compilers, and binary builds. For example, PyTorch depends on NumPy, MKL, and other C++ libraries under the hood. A tiny mismatch between your OS or compiler version can make build fail. The solution: don't build from source unless you need to. Use pre-built wheels or CUDA bug packages. They save you time and reduce random errors. Problem 4. Model and data version mismatch. AI apps aren't just code. They also depend on exact versions of your model and tokenizers. If your model weight comes from version 1.1, but your tokenizer is from version 2.0, you will get a strange or incorrect output. Same goes for datasets. Even a small preprocessing change can shift your model's accuracy. The solution: version everything. Your models, datasets, and tokenizer. Tools like DVC or Hugging Face Ops lets you track and lock versions easily. Number 5, reproducibility across environments. Even if you have the same code and dependencies, AI models don't always behave the same on different machines. This can happen because GPUs handle floating point maths slightly different, or because the random seeds aren't fixed. The solution: always fix your random seed and log your environment details like binary versions, CUDA types, GPU types, CUDA versions. Tools like MLflow or weight and bias make this simple. Let's quickly recap the biggest dependency problem in AI development. 1. Framework and library version conflict. 2. CUDA, GPU drivers and CUDA incompatibility. 3. Deep dependency chain and binary builds. 4. Model and data version mismatch. 5. Reproducibility across environments. These are the hidden traps that makes building AI apps harder than traditional software. Thank you.